what do I get now? I'll get this part and these things as well. I'll do later. Okay. So I'll take 2 delta x common and I'll send it to the denominator. I have dou square u by dou x dou y at I comma j point can be approximated by this term divided by 2 times delta x. I have dou u by dou y at I plus 1 comma j minus dou u by dou y at I minus 1 comma j all divided by 2 times delta x plus, since I am taking delta x common, the leading term in the truncation series would be of the order of delta x squared. So this is second order accurate approximation for mixed derivative of u with respect to x and y. Now the question remains, how can I find these two guys? How can I find these two guys? We know that dou u by dou x at I comma j from second order central difference, I have u I plus 1 comma j minus u I minus 1 comma j by 2 times delta x. This is second order scheme. I can write the same equation in y. Dou u by dou y at I comma j is u I comma j plus 1 minus u I comma j minus 1 by twice delta y, and its order is dependent on delta y. So I have this term. I can get I plus 1 and I minus 1 by shifting this I index by plus 1 and minus 1. So what do I get? If I shift this index I by plus 1, so if I substitute I with I plus 1, what do I get? I get dou u by dou y shift I to I plus 1. I will be I plus 1, I will be I plus 1, I will be I plus 1 by 2 delta y. Nothing else changes. Okay, this is the first term and we got our first term. Let me get the second term as well. What is the second term? I need to shift I to I minus 1. If I do that, if I shift this I to I minus 1, what do I get? I get dou u by dou y at I minus 1 comma j is, instead of I get I minus 1. Instead of I get I minus 1 by 2 times delta y, and this is also second order accurate. So these are the two terms that we need to substitute there. Okay, let's substitute. I can take 2 delta y common. Okay, I can take 2 delta y common. Okay, the first thing is I'll write the truncation term. I get delta y square as well. Okay, if I substitute this term and this term and I send 2 delta y to the denominator, what do I get? I get 2 delta x times 2 delta y. These two are common, so this is 5, so equation 6. If I substitute this in my equation, what do I get? This is 7. If I substitute 5 and 6 in 7, what do I get? This is the first term I have. U I plus 1 comma j plus 1 minus u I plus 1 comma j minus 1, and these two terms as it is, plus, is it minus or plus? Check the equation that I got. Yeah, it's minus. So if I do a minus here, I get minus u I minus 1 comma j plus 1 minus of minus plus u I minus 1 comma j minus 1. This is the final equation for the mixed derivative, and it is second order accurate in both x and y direction. So how does it look like? What is the stencil? Okay, stencil is nothing but for the forward difference we had I plus 1 and I minus 1. Forward difference we are only using these 2 points to approximate the first derivative. So we call these 2 points as the stencil. Similarly, in 2D, say this is index I, this is I plus 1 and this is I minus 1. This is j plus 1 and this is j minus 1. What are all the points in this approximation? I plus 1 comma j plus 1, I plus 1 comma j plus 1. Next point is I plus 1 comma j minus 1, I plus 1 comma j minus 1. Next I minus 1 comma j plus 1, I minus 1 comma j plus 1, I minus 1 comma j minus 1, I minus 1 comma j minus 1. So this is the stencil for the mixed derivative approximation. Okay, I can simplify this as well. I can simply write it as 4 delta x delta y. This is also second order accurate in both x and y. So this is second order approximation for the mixed derivative. And this is the stencil that we get. So these are all the points that we need to approximate to get the derivative at I comma jth location. So to get the mixed derivative at this location, I need data from 1, 2, 3, 4 points.